This is the notes for properties of exponents, day 2. We've gone through our rules for exponential simplifying already, looking at all of these exponent rules from before. We're going to apply them further in this video. In this first problem, we are going to go ahead and simplify. We have an expression on the left being multiplied by an expression on the right. We're going to simplify each of these separately. We could apply the power to each component within this quotient. It seems like it's going to be significantly easier for us to simplify first. So we have 5 over 25. Well, that reduces to being 1/5. When you have when you have x to the 5th divided by x to the 3rd, it's x to the 5 minus 3. So we have x squared. In the y's, we have y to the negative 4th, and in the denominator, y to the 1st, which means we have, in all, y to the negative 4 minus 1, or y to the negative 5th. This means that there, at the end, will be, with this simplified expressions, be more powers of y in the denominator than there were in the numerator. There is negative powers in the numerator, and there's a positive power of them in the denominator. Z to the 7th divided by z to the negative 8th is z to the 7 minus negative 8, or z to the 7 plus 8, which is z to the 15th. We've done that all before applying the power of negative 2. We have, on the right-hand side, we can apply the power of 2/3 to each component. Now, let's go ahead and let's just finish off this right-hand side. 8 to the 2/3 power, we're not going to multiply 8 by 2/3. 8 is a base, so we have to take 8 to the 2/3 power, which that means we can cube root the 8 first and square it, or we can square the 8 first and then cube root it. I consider it usually easier and faster to cube root the number that we're working with first. The cube root of 8 is 2, squared is 4. Then in this power to a power situation, you can multiply the exponents. 9 times 2/3 gives us x to the 6th, and y to the 6th to the 2/3 gives us y to the 4th. Over here with the negative exponent, there's two things that we could do. We could either reciprocate everything first, doing the negative power, or apply that negative second power on each component. I think it's going to be easier here to apply that negative second power to each. I'm going to get rid of those parentheses that I put down before. I don't know if I'm going to need those. So we have 1/5 to the power of negative 2. X to the second to the negative second is x to the negative 4th. Y to the positive 10th. Z to the negative 30th. When you go take a fraction to a negative power, you can reciprocate it. That's doing the negative portion of the power. So you could go 5 to the second here, which is 25. So we have 25, x to the negative 4th, y to the 10th, z to the negative 30th, times 4, x to the 6th, y to the 4th, which will simplify further to be 100. X to the negative 4th times x to the 6th is an x to the positive second. Y to the 10th times y to the 4th, we add those exponents to get y to the 14th. And then we don't have anything to multiply the z to the negative 30th by. So we could write z to the negative 30th, or since it's a negative exponent, we can write it as a positive exponent in the denominator, which will give us our end answer. Now, on our second problem, there's a lot of radicals here. It says simplify and rewrite an exponential form. So we're going to look at this instead of as a radical, as a exponential. We have this cube root and this fourth root. We know that cube roots and fourth roots are fractional exponents. So we have x to the 36 y to the 17th, a to the negative 12th, b to the negative 15th. Well, it's being cube rooted, so that's the 1/3 power, and it's being fourth rooted, that's to the 1/4 power. Well, we have a lot of stuff here. We have these exponents out here. So we have power to the power types of situations. So we have x to the 36th, y to the 17th, a to the negative 12th, b to the negative 15th. This power to a power, we can do this as 1/12. We can apply this power to each component. So we have x to the 36th to the 1/12th, y to the 17th to the 1/12th, a to the negative the negative 12th to the 1/12th, and we have b to the negative 15th to the 1/12th. So since we have a power to a power, we can go ahead and we can multiply our exponents again. So we get x to the 36 divided by 12, which is 3. Y, 17 divided by 12 doesn't simplify, so we can just leave it as 17/12ths. And then a to the negative 12th to the 1/12th is a to the negative first. And then b to the negative 15th times 1/12th is 15/12ths. Well, it's asked us to rewrite this in exponential form. We're going to leave this in exponential form at the end. I just lost it. There it is. So we have x to the third, y to the 17/12ths, and the denominator a to the first, b to the 15/12ths. Now, some of these came out really nice, reduced really well. I definitely could simplify that 15/12ths. Both of those numerator and denominator divide by 3. That was too big of an eraser. So divide 15 by 3 to get 5, divide by 12 by 3 to get 4, and here would be our answer. We're going to simplify and rewrite in radical form. Often working with exponents is pretty helpful to us, so we're going to keep it in that form as long as we can. We have 27 to the 2/3 power, x to the 21st to the 2/3 power, which we can multiply. 21 times 2/3 is divided by 3 and then multiplied by 2, so that's 14. And then y to the 10/3, because that's the 5 times 2/3, power to a power. 27 to the 2/3, we don't multiply these together because this is not an exponent, this is a base. So 27 to the 2/3 means that we cube root the 27 first, and then we square it. The cube root of 27 is 3, 3 squared is 9, so we have 9, x to the 14th, y to the 10/3. And it says it wants us to rewrite in radical form, so it means we got to leave our end answer in radical form. There's only one radical here. That's the 1/3 power. So you have x to the 14th, y to the 10th being cube rooted. Now in 4 and 5, we have all these radicals. It's going to be easier to move these to be exponents with the same base. Because what's happening here is this square root is really a half power. We get 125 to the 1/2 power. And then we have 25 to the 1/5 power. So we've worked them into exponential form so far, but there's more. 125 and 5, you should notice that they both have bases of 5. 125 is 5 to the third. So we have 5 to the third to the 1/2 power, and we have 5 squared to the 1/5 power. Well, since we have a powers to power on both of these, and power to power in the numerator and denominator, you can go ahead and multiply those exponents together. So you have 5 to the 3/2 over 5 to the 2/5. And well, now they're the same base in terms of a quotient. So when you do a quotient, We have 5 to the 3 halves minus 2 fifths. So 5 to the 15 tenths minus 6. Nope, that's totally wrong. To get to tenths, I got to multiply both the numerator and denominator by 2. So that's 4 tenths. So we have 5 to the 11 tenths. It doesn't look like I specified which form I wanted you to put in here. This would be acceptable without me specifying form, or we could do the 10th root of 5 to the 11th power, which would be the same thing as 5 times the 10th root of 5. In our last problem, we have this numerator is a 1/5 power, so we have 7 to the 4th to the 1/5, and we have 7 to the 11th to the 1/6 power to a power. We multiply these exponents. So we have 7 to the 4/5 and 7 to the 11/6. So we can do 7 to the 4/5 minus 11/6. To be able to subtract these, we can get to a common denominator, which is 30ths. This is 24 30ths minus 55 30ths. So this is 7 to the negative 31 30ths, which you could write in either of these two ways. You could write it as 1 over 7 31 30ths, or you could I like that way the best. I really am not don't have an issue with this overall, but I'm going to want you to put things into only positive exponents. So you would move that to the denominator, saying that the negative exponent in the numerator is the same as a positive exponent in the denominator.